All right, welcome to Math 135, section 1.2. We're looking at things called relations and functions. All right, so we have a few different ways of showing our work for our answers, and they are set builder notation and then interval notation. And let's take a look at this chart. Feel free to pause this video and look at this while I'm reading over it. I'll kind of skip over this a little bit as it would be considered still sort of in the review section. Again, please pause the video and review this. I'll just do a quick talk about it. So real quick, we're talking about the different types of intervals. We have open intervals, and then the other different intervals, closed interval, disjoint, and then all real numbers. We have the way to show our answer with set builder notation, where you use x, and then that little straight down line is such that. So we have x such that x is greater than a in this one. And then interval notation would be from a to infinity. Please note for interval notation, if we're not including the number in the answer, we use that little open bracket like this. If we do include the answer, we would use the bracket. Sorry, I meant to say parenthesis. We use the parenthesis for interval notation if it's not including, and then we use the bracket when it is including. I think of a bracket as a staple. For example, if you're stapling two pages together, they're included to each other. All right, again, that is just a review on there. Please read through that definition page. Now take a look at example 1. Write each set using interval notation and graph each set. Alright, I'm going to go ahead and graph the set first, and then I'll use it to read interval notation. So for me, when you're graphing your answers, the main thing I want to see is you indicate where 0 is and then where your numbers are in relationship to 0. So I have 0 here, and then I'll choose 1 and then 10. I don't care too much about the spacing for these because they're just small sketches. Just please show me where 0 is and then where your numbers are. Now let's see. My x values are between 1 and 10, but it can be equal to 1. So I'm going to go ahead, and the way I graph is a little different than the above. You can still use the above definition for graphing, that's fine. I like to float it above the line though so you can see my work. We're going to include 1, so I'm going to fill in my bubble. That's what I use to define including 1. Again, if you wanted to use that little bracket, that's perfectly fine. I accept both answers. I like to use the bubble though, as mentioned. And then it's going to continue on until 10, but do we include 10? No, we don't. So I'm going to go ahead and use open bubble because we don't include 10. Or you could use your little parenthesis. So if you wanted to do it with the bracket and the parenthesis, this is what your answer would look like. Again, either option, I do not mind. I just prefer the one that I use above. All right, and then so that is that graph. And then how do I do interval notation? I'm just going to read my graph. Again, we read from left to right in English. So the first value I see when I'm reading from left to right is, boop, the 1. We start at the 1, and then we continue until we hit 0, but we don't include 0. And that's what my interval notation is going to look like. I start at 1, and I include 1. And then I continue on until 10, but I don't include 10, so I'm going to use that open parenthesis. Alright, feel free to pause the video and then try graph and write out the interval notation for these different sets. Okay, for B, so we're doing x such that x is less than 3. So again, show me where 0 is and show me where your number is. And we know my values for x are going to be less than 3, but they're not equal to. So I'll leave a little open bubble and then draw my line. And there we go. And then reading from left to right for infinity. Oh, shucks, I already said the answer there. But again, reading from left to right for my interval notation, where do we start on the left? Well, there's no starting number. We're all going all the way to infinity. And what kind of infinity? It's negative infinity. So since it's not a real number, we can't include it. So I'm going to go ahead and use the parenthesis. And then it goes and goes and goes all the way up until, boop, we hit 3, the negative 3, but we don't include negative 3, so again, open parenthesis. Now let's take a look at the next one. All x such that x is greater than or equal to 5. Okay, again, my 0, my 5 is above 0, and all my x values are greater than or equal to. So we'll go ahead, we know they're all on this side of 5, but we can also include 5. So I'll fill in 5 bubble. Oop, that's getting a little big and ugly now. Alrighty, there we go. And then reading from left to right, the first number I see in my solution is the 5, and we include it, so I'll use my bracket. And then it continues onward till, oh, how far does it go? It just keeps going onward to infinity, and positive infinity this time. And then again, we can't touch the end of infinity, so we can never include it in our answers, so that's why we use the open parenthesis. And there we go. Okay, so now let's move on to something called relations, or the domain and range of relations. So a relation basically is a set of ordered pairs, often written as x comma y, where the x values are called the domain and the y values are called the range. An easy way I think about this is, for example, if we're looking at the x values, oops, I should actually use green since I was using that for the x values, and the y values. If we're looking at the coordinate plane, the x values again are my horizontal values. If you're thinking about the land that you're walking upon, if a king has land, that is called his domain, right? It's that horizontal ground you're on. This is your domain, the domain that you rule over. And then let's say if you're at a shooting range or a gun range, usually you're shooting sort of up in the air, right? That'd be your range. Up into the air is your range, and your domain is what you're walking upon. That's the way I use to remember it. All right, so example 2, state the domain and range for the relation. So I'm going to list out the domain. I'll write out domain, by the way. So the domain for this relation is going to be all of the, what values? The x values. Again, remember, domain is the x. That's going to be these values right there. -1, -2, and -3. -3 is used twice, but I'm just going to write it once. And then range. Again, write out range. Remember to label your work. Very important. Range, again, is all of my y values. Yep. And my y values are 1, 2, -3, and 3. You could write them in order. I'm not going to be particularly picky about that, but this would be acceptable. Again, you could write them in order, so that negative would go first. All right, let's take a look at the next ones. This one is listed out even nicer for us. These are my x values right there. Oops, I was using green. Those are my x, and those are my y values. Again, x values are my domain. Yep, that's correct. So listing those out, I get 1, 2, 3, and 4. And then my y values are my range. Those are my yellow numbers. 1, 5, -3, and 0. Again, my range values are my y, my domain are my x. So now let's move on into a bit more about functions. So a function is a relation. Okay, so we're building upon this. Think about, for example, if we're talking about the world of dogs. Inside the world of dogs, there are also some types of dogs called pugs. It's the same thing we're doing here. There's the world of relations. And now we're looking very specifically into the world called functions. Okay, they're very specific relations. So what do we know about them? A relation is a function in which every element of the domain corresponds with exactly, this is very important, exactly how many? One element in the range. Okay, very important definition. Every x value has exactly one y value. Again, every x has only one y. Think about this in the traditional concept again of marriage. Each x spouse has their one y spouse. So let's take a look at the function machine. This is just a generic example. Your input are your x values. You'll input it into the function machine, and then the output value would be my y value. So every input will only have one output. If we input something in to the function machine, the output should be very unique to that x value. Okay, so let's see. Function notation. If y is a function of x, in other words, y depends on x, then we write this very special function notation, y is equal to f of x. Again, notice here with our function machine, the output depends on what we input into it. Again, that's where we have that. And then so we call x the independent variable and y the dependent, because again, it depends. This value greatly depends on what we input into the function. Example 3, state the domain and range for the relation. Is this relation a function? All right, so let's go ahead and state the domain. Again, the domain are my x values. The range are my y values. So the domain is 1, 1, 3, 4. And the range is 0, 2, 4, and 6. Now let's see. Are these functions? Well, again, by definition, each x value should only have one matching y value. So ask yourself, take a look at the x values. Do they have only one y value? The answer for this one is no. Look at this. X appears once, but one time it's saying x has a relating value of 0. Another time it says x's output is 2. This x value has a 0 and a 2. That does not make sense for functions. So this may be a relation, but it's not a function. Not a function. And then you write your reason. The x equals 1 has 2 y values. Okay, again, and stating your reason on why you said no. All right, let's take a look at the next one. We have, okay, so this is going to be some set notation. X comma y such that, again, that downward line there means such that y equals x plus 1. Let's see. Is this relation a function? And what is the domain? Well, if we were to graph this, again, so hopefully assuming we've all had practice graphing lines entering this class, this would graph some sort of a line with a positive slope at the y-intercept of 1. So if I was to look at this, the domain of a line like this will be from negative infinity all the way to positive infinity. It's going to cover all of those. So I'll write out my domain as negative infinity to positive infinity. And then the range is very similar. My lowest value, negative infinity, and then it goes all the way up to positive infinity. So the range for, or the domain and range for most lines is pretty much negative infinity to positive infinity. Not all lines, bear in mind. Okay, so then let's see. For each x, is there only one y value? Well, the answer to this is going to be yes, and the main definition on that is actually right below us. But if you wanted to just visually look at the graph, if I picked an x value here, what is the matching y value? Well, there's only one that exists right next to it. So the answer to this is yes, it is a function. Each x has only one y. And then box your answer. Alrighty, let's take a look at something called the vertical line test, which I just mentioned is very useful. Now, the main use of a vertical line test is when you're given a graph. Bear that in mind. So vertical line test, again, this is for if we're talking about functions and we're trying to decide if a relationship is a function. If every vertical line intersects a graph at no more than 1 point, then that graph is a function. Okay, again, so the test is, if I was to drop a vertical line as many times as I wanted to, and it only hits my graph in 1 point, no more, then it is a function. All right, so example 4, state the domain and range for the relation. Is the relation a function? Okay, so taking a look at this first one. Again, this is just a good regular old line like the one we just did above. So let's go ahead and try the vertical line test on it. Actually, real quick, let's do this domain and range first. So the domain, again, reading from left to right for my domain, the farthest we have to the left is going to be negative infinity, because remember that arrowhead indicates that it goes on infinitely. And then it goes onward and onward till, again, arrowhead positive infinity. Okay, let me erase that work. All right, and the same concept is going to apply again for the range in this case. If we're looking at the y values, reading from down up The furthest down it goes is again negative infinity, and then it continues going upward, 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 upward to positive infinity. So that means my range is also going to be negative infinity to positive infinity. Okay. So now, is this a function or not? Well, let's go ahead and do that vertical line test. Let me drop a vertical line. How many times does it hit my graph? Only once, right there. Let's drop another one. Oops, only once. Another, oop, only once. And every time I drop a vertical line, no matter how many times I drop it, what happens? It only hits my graph in one place, which means it is indeed a function. So again, we'd answer, yes, it's a function, and then my answer or my justification would be by the vertical line test. So it is a function. Oops, let me write that a little better. A function by the, and I'll just shorthand it VLT, vegan lettuce and tomato. A vertical line function. All right, so let's take a look at the next one. Ooh, now this is weird. You're going to be graphing these in this class. This is the ellipse instead of a squashed circle. So let's see. Again, we got to find the domain and the range. Now, but this one's different. I don't have those arrowheads extending on into infinity. So to be a little more careful. Again, my range are my allowable x values. So the ones I'm using go from here to here, just that. What x values are that? That's -3 to +3. And that's all I'm using for the domain. And am I including them or not? I am including them, so I should really be using that little brace right there to +3. And again, including. Now let's take a look at my, range. I really should be doing that in green because I was using green earlier. This my domain was in green. Now my range is going to be from this point to this point. And again, we're looking at the y values for range. That's going to be -2 to +2. And I'm including them. -2 to +2. This range is very different than my line. But again, be careful. Arrowheads mean on to infinity. Without the arrowheads, you're looking at some very specific points. So now, is this a function? Pause this video and try to find out by yourself. Okay, so hopefully you paused it and tried the vertical line test, because again, that's what we're working on right now. So if I was to drop a vertical line right here, boop, it would hit my graph in only one point. So you might say, wait, it is a function. But careful. If I was to drop any vertical line through this graph and it hits it more than once, it's not a function. So notice, when I drop it down this way, it hits it here and it hits it here. It hits it twice, which means it's not a function. So this is going to be, this is not a function. And what's my justification? By the vertical line test. And then we are done. Okay, so moving on. Let's sketch a graph by plotting points. All right, so let's take a look at the first one. f of x equals x plus 1. Now this is a linear equation. How do I know that? Well, this is just x to the 1 power. So this is going to be a linear equation. And when we have these, I only require you to graph 3 points. All right, so how will we graph by points? Well, I'm going to use an XY table. I'm going to pick a point and then plot a point. And usually when we have function notation, again, function notation is where we have f of x. And remember, f of x is a nickname for y. It's the same thing. It's just like calling somebody by their last name. Like if you watch Harry Potter, people call him Potter a lot. It's the same person. So f of x is the same one as y. So I'm going to pick a value for x. Let's say, I usually like to pick, if possible, a negative, 0, and then a positive. So I'll pick -2, 0, and then a +2. I'm going to test these 3 values to find the corresponding, that should have been a y value. So if x is -2, my function is saying, take that input of x and then do what to it? It's telling me to plus 1 to it. Take x and then add 1. So my x value for the first one is a negative 2. And then we're going to add 1 to that. And that's going to be negative 1. For 0, that's going to be 0 plus 1, which is 1. And then 2 is 2 plus 1, which is 3. So the pairs that I have are, I'll just write them out, negative 2, negative 1, 0, 1, and 2, 3. So let me go ahead and graph those. Negative 2, negative 1. Let me do it a little bigger so we can see this. Negative 2, negative 1. And then, again, please remember to label your points. 0, 1. So 0, 1. And then 2, 3. 2 and 3. Okay, again, just 3 points for the linear ones. Draw in your arrowheads and your line. Okay, I do check that you put your arrowheads on your line. If it's supposed to go on to infinity, please make sure to indicate that. All right, and there we have our line. Next, we're looking at f of x equals 2. Interesting. Now, this one is still technically considered linear, so let's go ahead and figure out how to graph this. My table of contents, or sorry, my table of values. Let's pick, again, I'll do a negative 0 and a positive number. X is 0, or sorry, x is negative 2. X is 0 and x is positive 2. Again, negative 0 and a positive. Usually the ones I pick. There are times when you can't pick these numbers, but it's a good sort of direction to take is always to pick a negative, 0, and a positive. So if I pick x is negative 2, what are my directions saying about y? Y is going to equal 2. Just 2. In fact, it doesn't matter what my x value is. My y value is always going to equal 2. Now, this is considered a constant function. Regardless of what my x is, my y is always going to be 2. So what type of a line looks like that? Well, if x is negative 2, y is still going to be 2. Negative 2, 2. If x is 0, y is still going to be 2. And if x is 2, y is still going to be 2. So what does this end up graphing? It ends up graphing a horizontal line. Alrighty. And for fun, try to check if these are functions or not. Again, using the vertical line test, you'll see that these are both functions. They both pass the VLT. All right, so let's take a look at using function notation. So for example 6, find f of x for the given value of x. We're given that f of x equals x squared plus 1, and we're told to input x equal negative 1. Which means everywhere I see x, I'm going to input it and swap it out with a negative 1. So let's see. F of, and again we're swapping out x with negative 1, is going to equal my x value squared, so negative 1 squared, plus 1. And that's going to equal negative 1 squared is 1 plus 1, which is going to equal 2. So f of negative 1 is going to equal 2. And voila, we're done. All right, go ahead and give a try for the next ones and see what you get. So b, this is going to be f of, now this time we're swapping out x with negative 1. So x of negative 1, still sort of the same thing, but my function is different. I have that negative on the outside. Be very careful. That is still on the outside. So we got negative 1 and then plus 1. So that's going to be the opposite of negative 1 squared, which is still a negative 1 plus 1, which is 0. So f of negative 1 this time is 0 because my function is different. Just by that small little negative sign, which again I said before, be careful with those negatives. They are sneaky. Let's take a look at the next one. F of x equals the square root of 2x plus 4, and we're given this time that x is 0. So we're going to go ahead, plop, and replace that x there with 0. So f of 0 is going to equal the square root of 2 times 0 plus 4, which is going to equal 2 times 0 is just going to be 0 plus 4, which is the square root of 4, and the square root of 4 is just 2. So f of 0 is going to equal 2. Let's take a look at the next one. Ooh, this time, what are we given for x? We're given a negative 2. Again, please be very careful with negatives. They can be tricky. Please make sure to use your parentheses. So we have a negative 2 equals the square root of 2 times negative 2 plus 4. I'll go ahead and input that negative 2 equals the square root of 2 times negative 2 is negative 4 plus 4. Ooh, and negative 4 plus 4 is going to equal 0. That'd be the square root of 0, and the square root of 0 is just 0. Again, if you need any practice on simplifying square roots, please let me know, and I'll send you a worksheet. All right, and for the not last problem, but nearing last problem of this section, for the function f of x equals 2x minus 7, find f of a, f of 2a, and f of a plus 1. So 3 different things. So I want f of a, f of 2a, and then f of a plus 1. So don't get too nervous. Again, we're just replacing whatever's on the inside with that x value. So this case, instead of x, we're going to write it with an a. So this is just going to equal, swapping out that x value, 2a minus 7. And we're done. Not bad, right? Next, we're given f equals 2a. Again, don't be scared about it. This is just a 2a, so we're just going to swap out that x with the 2a. So that'll equal f of a equals 2. Again, remember just multiplying 2 times whatever is in here. And the thing that's in there this time is a 2a minus 7. So this will be 4a minus 7. So f of 2a equals 4a minus 7. Now let's take a look at the last one. This one's a binomial being thrown in. But again, don't worry. Wherever you see the x, just swap it out with that binomial. So this is going to equal 2 times my whole binomial plus or minus 7. And my whole binomial is a plus 1. And we can go ahead and distribute that 2 in as well. So that'll be 2a plus 2 minus 7. Simplifying these like terms, that'll be 2a minus 5. So f of a plus 1 is 2a minus 5. And we're done. Not too bad. Color coding usually works really well if you need to do that. Example 8. For the following graph, find f of negative 2, f of 2, f of 6, and f of 8. Okay, so there's different ways to do this. I'm going to go ahead and make a table of contents. Okay, so let's see. Remember, the input values, I'm used to seeing f of x, which means that these numbers here, let me go ahead and highlight them, these are x values, the numbers on the inside of the parentheses. So I just need to figure out what the y values are for these, remember, because f of x equals y. So I'm looking at negative 2, positive 2, 6, and 8 for the x values, and I want to see what the matching y values are. So let's go ahead and look on this graph to figure out where negative 2 is. So here's negative 2. What's the matching y value? Well, it's down here, boop, at 4. So the matching y value is 4. So I will write for my final answer, f of negative 2 equals 4. Now, let's see. X equals 2 right here. Matching y value is negative 2. So then f of 2 is negative 2. And then let's see. Go ahead, pause the video and try the other two by yourself. Let's see, when x equals 6, the y value is, oh, this is the sneaky one, 0. So f of 6 is going to be 0. And then lastly, we have f of 8. Here's my 8 for f, and then the y value is, oh, it's kind of a in between, so I'm going to go ahead and say that's a 1. 8 and 1. So f of 8 equals 1. And there we go, my answers. Okay. Let's see, example 9. For the following graph, find f of negative 4, f of negative 2, and f of 1. Okay, so same kind of a deal going on here. Feel free again to pause the video and try this out by yourself and check in with me. Let's go ahead and color coordinate these x values. Again, we're just using the definition that f of x equals y. So I'm looking for x values, or the matching y values, for -4, -2, and 1. When x equals -4, let's see, how are these tick marks going? 1, 2, 3, 4, 5. Okay, this is -4. My matching y value is here, which corresponds with 1, 2. So that's the point -4, 2. So then my y value, f of -4, is going to equal 2. Let's look for -2. 1, 2, and this is my y value. Let's see, the matching y value there is going to be 1, -1. So f of -2 is going to equal -1. And then for x equal to 1, let's see, that's a +1 right here, and what's the matching y value? It's just going to be a 0. Okay, so you don't have to get thrown off by the fact that this looks like a really strange graph. Still just follow the concept there, find your value you're looking for, and find the matching x value, or the matching y value. So this will be f of 1 equals 0. And we're done. All right. Oh, and we are really done. Okay, that is the end of this video. Again, if you have any questions, feel free to email me. We can set up an office hour, or we can just communicate via email. And if you need any review on any of these subjects, again, I can send you a worksheet. That is it for this video. Please let me know if you have any questions.